Hello friends, I am Smit Vora. Currently I am pursuing Information and Communication Technology at Harvard University. Today we are going to work on a project that is parallel binary adder using half adder and full adder, which comes in our one of our subject, that is digital electronics, and we are implement in the software part, that is object oriented programming through Java. This project is guided by Professor C.D. Parmar sir and Professor Kumar Anand sir. Now what is adder? Adder. In electronics, an adder is a digital circuit that performs addition of numbers. In modern computer also, adder reside in the ALU, which is the complex circuit of the computer. Now, there are two types of adder. First is half adder and second is full adder. Half adder. The half adder accepts only two binary digits of its input and produce two binary outputs, that is sum and carry. This is the block diagram of a half adder circuit. Now, this is the internal structure of the half adder, which includes one XOR gate and one AND gate. This is the truth table of half adder through which we can do some of the calculations. Now what is full adder? The full adder is that which can accept two input and one input carry that generates sums and output as a and one carry as a output. This is the block diagram of the full adder circuit. Now full adder consists of two half adder only, and in front of that one OR gate is connected. This is the internal structure of the full adder circuit, which is the sum of two half adder and one OR. Now this is a sorted form of full adder circuit that includes two half adder and one OR gate. This is the truth table of the full adder. Now the main drawback of half adder is that we can only add two binary digits, but it is fulfilled by the full adder, which can add three binary bits. But for n bits, it is fulfilled by parallel binary adder. What is parallel binary adder? Parallel binary adder consists of full adder connected in a many number of chains where the output and carry are connected with each other, and the next output is produced through which we can get the desired output of n bits. The n-bit parallel adder requires n full adders to perform the operation. This is the block diagram of the parallel binary adder. Now we are going to our code part. We are using one software, that is a IntelliJ IDEA software based platform on Java, through which we can do code easily through Java. Now this is my project, which I implemented and do the code and do the frame on the our desired project. Now this is the code of the first page, which we had made through frame, and we have included number of text fields, buttons, and many other parts, which we are doing in our project part, which makes our project better. There are almost number of classes which are we have implemented in this. Now let's run the project. We are running. Now our first page is opened. See, these are the basic introduction which I given in the previous session. Now clicking the button entered, we are entered in the next page. There are three options you can see here. There are the buttons, three buttons, and this is the exit button and this is the back button, which can move toward previous page or frame. Firstly, we are going to give to the introduction of half adder, which I made through the code. Here we had provided one picture in the background, through which user can get the some of the information. clicking the button enter. This is the text field, and this is the label diagram through which user can understand easily. Here we have to enter the two values, because in half adder we put only two inputs and sum and carry is produced. We can only put binary digits, so we cannot put any other digits. So we are entering first of all 4, 5, 6. Nothing is entered. But when we enter 0 or 1, that will take into the consideration. Now to see, we 9, 8, 7, no one. We put 0, so it takes. But when we put second digit also, that then it will not take. See, 0, 0, not taking. Here we are entering 1. Next digit, no consideration. Now we are pressing the OK button, which will provide our required output. See, here we entered 0. It moves to here 0, but it is not editable. You can see here easily. Here 1 is moved to this 1, and the XOR operation of 0 and 1 is 1. That produces the sum, that is our sum output, and 0 and 1 from here to here, and 1 from B, and it perform the AND operation, and the AND operation of 0 and 1 is 0. So our carry produced is 0. Similarly, we can do the reset button. So all the entered value will be gone. Now we are entering another. Let's say 1 and 1. And by pressing OK button, the required output will be given in the text field of sum and carry. You can see the desired output. Again pressing, so the text field will be given. And if we want the truth table, then click the truth table button. So the truth table frame is generated. While pressing the back button, it will come to the previous page. What is the Boolean equation of half adder? Then by clicking Boolean equation, we can see this the desired photo. That is the basic formula: sum is equal to A XOR B and carry is equal to A and B. Now we are pressing back button to go to the previous frame. Again we are clicking back button. Now we are going to give you introduction on full adder. Now this is the circuit diagram and somewhat the description of the full adder. Now we are pressing the enter button. These are somewhat the complex circuit, and we have to enter three inputs. As we said in the previous session, we have to enter one binary bit, that is 0 or 1, and not other bit is allowed. Let's say 2, 3, 4, no one is allowed, only 0 or 1, and that is only one bit. Let's say 0. Here we enter 1, and this is the carry. We have to take it consideration or not. Let's say we have to consider, so let's enter 1. So the value in the text field, you can see it. 0 comes to here, 1 comes from B to here, and performing XOR operation here and operation. Its output goes in the one OR gate, and this output goes in the XOR gate and AND gate. And so by operating the full circuit diagram, our output is produced, that is sum and carry, that is 0 and 1. We have to reset it. Let's say we click on the reset button, all the text will get vanished. Let's say another value, that is 1, 1, 0. We are taking carry as a consideration. Let's say okay. So the desired output will be different. That's we have to see the truth table. This is a truth table of the full adder diagram back, and let's see we have to see the full adder Boolean equation. That is the sum is equal to a x or b x or c in, that is carry input, and carry output a into b, that is a and b, or this is symbol of or, and c in into a x or b. This is the basic formula which is coming in the digital electronic circuit, that subject. Let's say we go to back part. Now we are going to our actual task, parallel binary adder. Here we have designed a 4-bit parallel binary adder which can take number of bits is equal to 4. Here we have to enter number 1 and number 2. Here also we can take only binary digits. Also the limit is 4 because we are taking 4 binary bits. Let's say 0 1 0 1. Other one is 1 1 0 0. Let's say OK button. The binary digit is 0101. Its decimal value is 5. You can see here. And 1100 BCD digit is, and its decimal value is 12. So, and we had performed this operation through the full adder. So, by taking the consideration, we are mixing all the full adders because we have to produce output in 4 bits. So we had taken 4 full adders and connected it. C0 is the initial value and C4 is the desired carry output. These are the inputs. Let's say 0101. That means you can see here 0101. So it considered in the form of A3, A2, A1, A0. This is 0101. And for 1100, it take in consideration B3, B2, B1 and B0. And the sum which is produced, that is S0, S1, S2, S3. And our desired output is calculated as C4, S3, S2, S1 and S0. So the desired output is 1 0 0 0 1. You can see here, and its decimal value is 17. So our desired output is produced because 5 plus 12 is equal to 17. This is the realization part. We can see we can do it in our book, or we can calculate it by this method, as we add two binary bits 0 1 0 1 1 1 0 0. 1 plus 0, firstly the carry is 0, so we had taken default as carry 0. So 1 plus 0 is equal to 1 in binary. Then 0 plus 0 is 0 because here no carry is produced, so here 0 carry is obtained. Therefore 0 plus 0 plus 0, the answer is 0. Here also no carry is produced, so here there came 0. Then 0 plus 1 plus 1 in binary, its value is 1 0. So 0 will be accommodated here and 1 will be accommodated here. So 1 plus 0 plus 1, again it is 1 0. So 0 is here and 1 is here. Now 1, that will directly come here. Therefore 1 0 0 0 1, that is our output. Now when we press the reset button, all the text fields are to be resetted. You can see it. Again when we press back button, we are at the frame, original frame, to select the options. When we press the exit frame, here we are the taken as a frame that gives the introduction. Special thanks to Professor Parmar sir, HOD of ICT department, who initiated the project of us, and Professor Kumar Anand Singh, who are teaching Java very deeply, and Professor Mehul Chandaria, our class coordinator of ICT department. Thank you.